Today, let's walk through how to select the input frequency for ADC dynamic test. In the test, we input a sine wave to the ADC. The ADC takes the value of this sine wave and quantize it at a sampling rate. The ADC outputs a series of numbers called samples. Note that these samples are discrete time values without time information. To analyze these samples, we use discrete time Fourier transform, DTFT. The spacing of discrete time samples is defined as 1 for DTFT. The first question is, how many samples do we need for the test? To answer that, we need to take a look back to the DTFT. Suppose we have NT samples. The spacing of frequency bin in the spectrum will be 1 over NT. We call it delta F. If we decide to collect more data by increasing the ADC data recording length, like doubling the total sampling number, NT, according to the sampling theory, the frequency bin spacing will be halved. The quantization noise will also be halved. This helps if we want to observe some subtle spurs in the spectrum. How many samples do we need depends on how small the signal you want to observe. If the signal is small and buried in the quantization noise, we'll need to increase NT by lengthening the ADC recording time. Let's discuss coherent sampling, a subtle but important point. Coherent sampling means in the sampling stream, the first and the last sample should be as close as possible. Why does that matter? Because if there's a big jump from the last sample to the first sample, this will create a discontinuity, and discontinuity will create spectral leakage, also known as Squarez effect. To reduce this leakage, we often use windowing function, but ideally, we'll just avoid the discontinuity in the first place.